Okay, hi guys. This term we're going to be looking at the different types of waves. So firstly, there are basically two types of waves. Okay, so we're looking at mechanical waves. Mechanical waves. So what mechanical waves are, they need a medium to go through. So we're talking about things like water waves or sound waves and things like that. The other type is electromagnetic. So those are probably the ones you're most familiar with. Electromagnetic. Now these ones don't need a medium, so we're looking at light waves and things like that. They can travel through a vacuum. That's how they can travel through space as well. In this first chapter, and probably the next chapter we do too, we're only going to be looking at mechanical waves. Okay, we will be getting onto light waves by the end of the term. So now in order to create a mechanical wave, you first need to create a disturbance. That's the whole point of it. It's a traveling disturbance. So you start off with a disturbance here, and the wave, it travels down, okay, as you can see here, and follows through. If it just happens the one time, so if it ends up something like that, okay, that's called a pulse. If it is a regular movement of the wave, then it turns into an actual wave rather than just a once-off pulse. Now, the other example that they tend to use a lot is like a pebble in a pond. So if you have a pond here, drop a pebble in the center and you'll see the waves radiating outwards. Okay. Now, a way to actually measure this is to measure the amplitude. So if you look at this one, for example, over here. Okay, so this is an example of a wave. Now, this measurement from here going up to here, okay, from the starting point up to the crest or down to the trough, that's a measure of the amplitude, and that's a measure of the amount of energy. If you're doing something like our pond here, okay, and so the ripple, you will see that the energy gradually decreases. So you'd be looking at something that kind of works a bit more like this. You've got your wave, you've got the center point, and it starts off quite large, and then as it goes on, it gets smaller and smaller. The amplitude gets less and less as you go down. Okay, so the amplitude here to here, as opposed to at the beginning where the amplitude's from here to here. Okay, so that shows the energy loss throughout it. So basically amplitude, okay, I'll write the definition here for you. So amplitude is the displacement of the wave from its starting position. So displacement from starting position. Okay, I hope you guys are taking notes through this as well. You will need to do that. Okay, so displacement of wave from starting position. Now, so when we're basically looking at this, we're looking at two really broad types of waves. Okay, so we've already said that they're mechanical and also electromagnetic, but this just divides all types of waves into two categories. First one, so you've probably heard this before. We've done this, plenty of times in class, and hopefully you would have done it in physics last year. So I'll just move this so hopefully you can see it a little bit more clearly. Okay, so the number one, and this one's the one that people tend to find a little bit easier to understand. We've got our transverse waves. So transverse waves. Okay, so these are the transverse waves like what I was drawing before. Okay, so you've got this kind of thing. Okay, now these transverse waves, the particles move perpendicular to the wave direction. So as you can see here, the wave starts at this point and it's traveling that way. But the particles are actually going up and down. So these are your little particles going up and particles going down. So they're actually kind of moving like this. Okay, so that actually means, okay, obviously it's perpendicular, okay, at a right angle to the wave direction, which is going along that way. Okay, so some examples. Well, the big one that you guys would know, so it's light or electromagnetic waves. Okay, water waves is another really good example. Alright, so that's your first type. The other one that you might find a little bit more difficult, okay, is the longitudinal or compressional waves. So I tend to call them longitudinal. Longitudinal waves, okay. Now these ones, they tend to use the example of like a slinky spring, Maybe you guys are too young for that to remember slinkies. Basically, compression up here, and then they have areas where they kind of spread out a bit more, and then areas when they come back to being compressed again, and then going to be spread out a bit more. Okay, so what we call these areas where they're compressed, they're compressions. Nice and easy. So areas of compression. These areas where it's kind of more stretched out, where the particles are not as close together, they're called rarefaction. So you've got rarefaction here. Okay, so areas of rarefaction and areas of compression. Okay, so when we're actually looking at this, of course we're using a slinky spring type look as an example, but what happens is, say with a sound wave, the particles get pushed together. Okay, there's a whole lot of particles kind of in this area, lots and lots and lots and lots. Whereas in this kind of one, because they've all been kind of compressed into this area, there's obviously less in this area of rarefaction. Okay, so that's kind of how a sound wave works. These kind of particles get pushed closer together and pushed away. Okay, and it kind of works like that. Okay, it's that kind of motion. Okay, so as I said, big example of this one, sound waves. Okay, that's the one we tend to know best. Okay, so as I said before, a single disturbance is a pulse, but if you have multiple disturbances, that's when it turns into an actual wave. So let's just quickly go through, I might grab this one, quickly go through the areas of a wave that you're going to need to know as well. Okay, so first thing we've already talked about is amplitude. So amplitude, okay, is right here. So I'll write amplitude for you. Okay, so amplitude is distance from its starting point. So this is your rest point here on the zero. Rest point right there. Okay. The other terminology you'll need to know up the top is a crest. Some books call this a peak. Okay, I don't mind which one you use. Crest or a peak is fine. And this down the bottom is a trough. Trough. So you've got your crest at the top, trough down the bottom. Now the big one that we're actually looking at is wavelength as well. So wavelength is the distance for one complete wave. Now often you take it from, say, the top, okay, so the distance between two successive crests or distance between two successive troughs. It doesn't matter which you do. I mean, you could really start from here as long as you finished up at the exact same point. So it needs to make one complete cycle, going up here and up to here if you're taking it from this point, point A to point B, okay? It's one complete loop, okay? Now, that's quite an easy one to see when we're looking at transverse waves. What does get a little bit more difficult is actually looking at our longitudinal waves. But what we basically say, it's the distance between the middle of two adjacent compressions, okay? So we say the middle is about there and there. So that would be one complete wavelength. Or again, you could do it from the middle of two successive rarefactions. So basically from here until, a bit off the page, about over there. Okay. So that would be a wavelength for a longitudinal wave. Now, frequency. So it's another terminology part of this that you do need to know. So frequency. Frequency, okay, so we call it F, alright. That is the number of waves passing a given point per second, okay. So waves past, it's either past a point or it can be just from the starting position, past the point per second, okay. Or we could actually say cycles per second. And that's actually how it's measured, okay? So it's cycles per second, or, of course, we can write it as CS to the -1. Either one, okay? Either one is fine. Now, you've probably heard of frequency. If you're looking at your stereo systems and things like that, you've probably heard of frequency being measured in hertz, okay? That is what hertz is, okay? It is cycles per second. So, hertz. And of course you probably know hertz is written as HZ. I'll move that over there so you can see it a little bit better. Okay. Now, so if we say 4 crests past the point per second, okay, so if we've gone, okay, so from here to here, okay, we've taken it from that given point, and that is 1 second. We will see that there is 1, 2, 3, 4 crests that have passed that point, okay? Therefore, the frequency equals 4 hertz, okay? 4 cycles per second, okay? Now, a period is the only other one that we want to talk to you about today. So it's a period of a wave. So that is the time taken for one full wave to pass, okay? Not too much more difficult. So period, I'll write this definition down for you. Time for one full wave to pass. So it's a different way of looking at the same thing, really. Okay, so we'd be looking, say, from this point, okay, all the way to this point, which you can see, okay, is one full wavelength, okay. If that is 4 hertz, we're quite easily able to work out the period, okay. So if we say, let's make the example, if we made another one, say if frequency equals 10 hertz, okay, that means 10 cycles per second. Okay. Therefore, it will take 1/10 of a second for one wave to pass. Okay. So an easy way for it to actually calculate that, we say period. Okay, and we actually use the symbol T for period. Nice and confusing for you. Period equals 1 divided by frequency. Nice and easy. So in this case, we've said 1, okay, 1 divided by the frequency, which we've said is 10. So it's 1 divided by 10. If we went back to this example over here, we said that the frequency was 4 hertz. Therefore, T equals 1 divided by 4. Okay, nice and easy. Seconds. Beautiful. That's all we're going to do today. So in our next lesson, we're going to move on to the wave equation. But we'll do a few more questions on this kind of thing tomorrow. Please make sure you've taken a few notes from this as well, because that's what I'm going to be checking to make sure that you've actually done it. So I want to see those definitions written down and having any questions that you want me to answer for you. Okay? See you tomorrow.